Swayam Prabha. Digital India. Educated India.
Today, I will introduce you to God. Okay? All right, so let's get started. A familiar figure. So let's say I have a plane in front of the object on the side and the back. On the top, the rays from the object come out to the plane. You get the front view. Likewise, you get the top view or the plan view, and likewise, you get the right-hand side view, something that you've seen before. Okay? If you flip open these planes above the hinges, you get the third angle projection, something that you've seen. Your frontal view happens to be in the third quadrant. And I said, well, if you are working with three views, the front view, the top view or the plan view, and the profile view, which is the right-hand side view in this case, if you're working with three views, and if it so happens that your frontal view happens to be in the third quadrant, it's third angle projection. Okay? Same thing, but in this case now the plane is at the back, bottom, and on the left-hand side, you let the rays emanate from the object and let them fall on these respective planes. Okay, you get the front view here, you get the plan or the top view here, and likewise you get the side view there. Again, if you rearrange these planes, your frontal view happens to be in the first quadrant. Okay, so remember that you're working with three views: frontal, top, and right side view. Right side view, not the left, right side view. And then I said that, well, in this case, if your frontal view happens to be in the first quadrant, then this is the first angle projection. And then my colleague, Professor Kishore, he visited me and he was like, well, if I remember correctly, I learnt it slightly differently. And then I had to jog my memory back. Well, back in 91, did I learn the same way or maybe I learnt it differently? So, and then I said, yeah, possibly I learnt it differently. I had doubts. And so in life, when questions bother you, then you already seen God, right? Why do you say no to that? You either refer to your Bible, your text, and just in case if you're not used to referring to your Bible, you pray. Okay? You pray to God. You may not be able to connect with the real God in a sense that, of course, you may be speaking to him or her, okay, but you may not be hearing his or her voice back. But this guy will try to come up with an answer. Okay? Okay? The answer may not be the one that you are looking for, but still, it will try to be as close as possible to the answer that you're looking for. So I did the same. I had doubts. I went to my God and I typed a few things. And this is what it came up with, different sources. And I'm going to be reading this text. First angle projection is like keeping a solid in front of a screen and seeing it from the other side of the screen. If I'm the object, I'm in front of the screen, okay, but I have to go back to look at myself from behind the screen. Okay? That's what it says, the first angle projection. It's from answers.yahoo.com. But it's not quite right, right? And that's the reason why I've marked this text in red. Seeing it from the other side of the screen. If I'm standing here, and if an image of mine, if an instance of mine, CSC 101, if an instance of mine goes back and looks at myself from behind the screen, okay, what will that instance of mine see? My backside, the mirror image, okay, which is not quite right. Fine. It is just projecting all the edges, points, features, etc. over a plane that is behind the solid, which is something that we have been doing, which is okay. Okay. Second source, this is from Wikipedia. In first angle projection, the projectors originate as if radiated from a viewer's eyeballs, okay, and shoot through the 3D object to project a 2D image onto the plane behind it. I'm just reading. In third angle projection, the projectors originate as if radiated from a 3D object itself and shoot away from the 3D object to project a 2D image onto the plane in front of it. Something that we have been doing. Okay? Consistent. Perfectly consistent. But from where does the first angle and the third angle, these names, come from? Not so very clear. So I was not satisfied. Okay? I kept asking God. And then I got something. In first angle projection, the object is conceptually located in quadrant 1. Now here is where the difference lies. So what I told you before was it was the front view that was located in the first quadrant. But this guy says that it is the object which is located in the first quadrant. Okay? Okay? Slight subtle difference. I.e., it floats above and before the viewing planes. The planes are opaque and each view is pushed through the object onto the plane furthest from it. And then it's talking about the projections. Okay? Same thing that we have been doing. Well, if you're not able to understand the text, it's perfectly fine. I have a graph. Imagine the space divided in 4 quadrants, quadrant 1, 2, 3, and 4. You see the frontal plane, you see the horizontal plane, and you see the profile plane. Okay? Quadrant 1, 2, 3, and 4, frontal plane, horizontal plane, the right-hand side plane, or the profile plane. Okay? So if you keep this object in quadrant 1, okay, and this is the important point. If you look at this object from the right, this is the important assumption. If you look at this object from the right, that means from here. If you look at this object from here, and if you let the projections emanate from this object and get back onto the frontal plane, what would you get? What would you get? Louder. Front view. Likewise, if you let the projections emanate from this object and hit the horizontal plane, flip it over, what will you get? The top view. Okay? And if you let the projections come out of this object, hit the profile plane, what do you get? Which profile? Who said left? Who said right? Which one is right? Which one is? Got to be careful. Where are you looking? So, where are you standing with respect to the object? Left hand side or the right hand side? You're standing here. You're standing here. What would you get on this profile plane? Left? Okay? So this is where the nomenclature comes from. Okay? But if you realize, you're smart, if you realize, if you're in the first quadrant, And if you open up the views, you'll be essentially getting the frontal view in the first quadrant. Okay? Similar, subtle difference. Okay? One thing that you need to remember again is in this nomenclature, you have to be standing or you have to be looking at the object from the right. Okay? In third angle projection, the object is conceptually located in quadrant 3. Forget the rest of the text. Look at the car. Okay? Once again, you're looking at the object from the right. Once again, you're looking at the object from the right. You're standing here. Okay? But it is this plane which is intercepting your view. In a sense that this plane is in between the object and yourself. Okay? You do the same exercise, you get the front view, you get the top view or the plan view, and then you get the right-hand side view, flip it open. What you will be getting would be the third angle projection. Once again, in there, if you're looking at 3 views, front, top, and right, FTP, okay? Your frontal view will be in the third quadrant. Okay? All right. There's this anecdote which is again philosophical. But with respect to TA 101, you have to have an eye for the drawing. That comes with practice. That would not come straightforward on a plate for you. It comes with practice. You have to have an eye for the drawing. Okay, if you don't have it, develop it. Okay, and that's the reason why I call this course Think and Analyze. And I encourage you to make mistakes, like I do. I'll tell you about some of my mistakes that I did, which you have absolutely no idea about. Okay? I encourage you to make mistakes because that's how you learn. That's how you develop the eye. You make mistakes, you realize that you have made a mistake, and then you say, well, fine. Next time, when something similar happens, I won't try to make a mistake, or I won't try to repeat the same mistake. Okay? I encourage you to make mistakes and learn from it. For example, you must have done this problem in lab 2. Huh? What is wrong with this? Okay? Even I didn't realize until, what's your name? Shreya. Mentioned that there would be a line here. Okay? There would be a line here. Would there be? Would there not be? Because that represents the line of intersection between 2 planes. The plane at the bottom, the plane here, and the plane here. Do you agree or do you disagree? Agree or disagree? Agree. Good. Okay, first mistake, which went, this is the problem that you are doing currently. So people in Monday's batch and people in Tuesday's batch, okay, they are working on that. Well, the dimension is not there, so you can assume the dimension to be 10. So for those who have done this problem, they may have assumed this dimension to be 10. For those who don't, take it as 10. But this is not what I'm referring to. I'm referring to something more fundamental, which Ria pointed out to me. She is one of the tutors in Monday's batch, right? Thursday's batch. Okay. Okay, watch carefully. Do you see any mistake in this? You do? What is it? One extra solid line, which is where? Where is it? Front view. This one? No, but this one? Are you referring to this one? Yeah? Any other mistake? Yeah? This line? Should it be there? Should it not be there? Okay? These are subtleties, and which is very, very difficult to kind of keep in mind. Okay? It's very easy for us to miss out on these subtleties. Okay? And yeah?
I guess there is one more mistake. Like those two dotted lines.
Which ones?
Which are for the sarcasm.
Which are for the what? Circle.
Yeah, the two dotted lines in the profile. They should be equidistant from the lens.
This thing should be equidistant from where? It is, no? From here and here. You mean this one? Okay. Okay, so third mistake. Okay, so the point of emphasis is that you have to develop an eye for the drawing, and I'm so very glad that you are pointing these mistakes out, helping me learn and helping yourself learn. So in this solution, for example, there was a mistake that I realized just today, which is what? Okay, so in the solution that I had discussed in the previous class, I had shown this line. Okay, this line would not be there. Okay? So there was this discrepancy. I may have said something else in class, and you guys, when you're doing the lab, you probably read the question slightly differently. So let me clarify that when I ask you to use isometric scale, I would do that when I ask you to work with isometric projection of view. Okay? So isometric scale is something that you need to be using when you're drawing isometric projection of view. Okay? But you're going to be using the true scale when you're drawing the isometric drawing. I probably may have said it the other way around in this class last time, right? Yeah? Okay. So today it's about missing lines and views to help you develop an eye for the drawing. I want you guys to open up your sketchbooks and pens and start working with me. Yeah? One is to 2 by root 3. Under root 2. That would be a smart way of ignoring the isometric scale, won't it? Huh? Won't it? Yeah, so I don't expect that. Let's take a look at this set of views. Third angle projection. Draw them in your sketchbooks quickly. This is where you'll also hopefully appreciate the importance or import of pictorial view or isometric drawings. Okay? So let's say this is the object, and somebody asked me a question here. Yeah, so something which is of importance to you now. Is this correct? Good. Let me quickly draw the basic projection or construction lines. Okay. Now, I'm trying to rectify these drawings. I look at this point here. Okay, in section of 2 lines, I look at this point here. Okay. If I project this point onto the plan view or top view, I'll see something. Okay, and if I project this point onto the right hand side view, I'll see something. Okay. Now, if I have a point in one of the views, what would I see in the other two views? Lines? Lines? Huh? And are they going to be perpendicular to the hinge lines, or are they going to be parallel to the hinge lines? They'll be perpendicular to the hinge lines. Okay? I take a look at this point, I project this thing upwards, I take a look at the corresponding image of this line, this point over there, which is a line in the right hand side view. Okay? So what do I expect there in the top view? Straight line, horizontal, vertical, slanted? Good. Okay? Simple exercise of correlating different features in different views, which you would soon realize is not that simple. Okay? So I want you guys to be with me and glue your eyes onto the screen. One eye to me, the other one to the screen. Okay? How about this point here? What do I expect to see? Just a portion of the vertical line. I expect to see only a portion of the vertical line. Why is that? Because if I took a look at the image of this point in this view, okay, I see only a portion of this line. Okay, I don't see the entire line, but only a portion of this line. Okay, so I project this line upwards onto the left to the top view, and then I get this. Good enough? Okay, what do you propose? Huh? I'm not done yet, man. I mean, I'm not saying that this set of figures is complete now. Okay? Now, look at this point here. Image of this point in this view is a horizontal line. Okay, what do you expect? Look at this point here. Image of this point in this view is again a horizontal line. What do you expect there? Am I done yet? Yes? Would I see a line here? Here? Done? How would my object look like? How would my object look like? Can you figure? Not straightforward? Yeah?
We basically have to assume that basic lines are only in the top view, because otherwise we would think of many more configurations.
I'll come to that. I'll come to that. Possibly, if you sketch it out, your object will look like this. Agreed? Agreed? Okay. Still thinking? Okay. Example 2. Let me quickly draw these construction lines. So I'm not showing these construction lines because they are quite obvious. I'm not showing these lines. Okay, they're quite obvious. So the idea is you look at the three views, you look hard, you look harder, and then you try to figure which of the features in which of the views are not related. Okay, for example, this guy here. Okay, this point here, you don't see the corresponding image in the front view or possibly in the side view. Okay? So what do you expect here? No. So let's break it down. So lines and rectangles. So what do you actually expect here? A line? Yes, no? Horizontal, vertical? This is a slant line here. The image of this slant line here would be horizontal? Huh? Convinced? Always? Always? Not always. But in this case, maybe it is. So you see a vertical line, you see a vertical line, and you would see a horizontal line. Okay? Rectangle. Some of you had mentioned that. Is that it? Is that it? This is how the object is going to look like. Okay? This one. Let me quickly draw projection lines again, construction lines. Okay? This feature here is related to this point on the right side view. This dotted line in the top view is related to this point here at the bottom. So far so good, no changes in the three views. How about this guy? Huh? A point, image of which would be a horizontal line here. Go up, you only see a horizontal line here. Okay? This would be a solid line. How about this guy here? Dotted line. Is that it? This is how your solid is going to look like in pictorial view, pictorial sketch. Okay? So try to realize what I'm trying to do here. So I'm just working with the three views given to me. Okay? And what I'm trying to do is I'm trying to correlate different features in different views with other views. Okay? Okay? And then once I figure that, okay, fine, I cannot go any further from there, and I assume that the three views that I have constructed are okay and are correct, okay, and then I attempt to sketch this three-dimensional solid. Okay? But this approach is not always applicable, as in this approach will not always work. Okay? You will have to draw the pictorial view as and when you are making revisions to your orthographic views. This one, for example. So I need your help in this one. Work it out, 2 minutes. Think about that and tell me which features are missing in which views. Ready? Yes? No? Okay. How about this point here? What do you expect? A part of it would be a line. A part of this vertical line would be a line. Which part? Okay, I go from the right. Okay, this part would be a line. What else? There would be a horizontal line. And this would correspond to what? So you're suggesting that there would be a line here, horizontal line here. And this would be the image of which feature in this view? This arc? Okay. Complete horizontal line? Hold on. Okay. Let me address this point here. Okay, so this is intersection point here. Would there be a vertical line? Yeah? Yes or no? Okay. Would this part of the line be there? Okay. And then somebody says that there would be a horizontal line. Yeah? Is this how your solid is going to look like? Small mistake. Okay. Where? It's there. This one. This. Can you come up? Avikalp suggests that there should be a line here. You sure are thinking, you sure are analyzing, and I'm very happy about that, which is what I want you guys to do. Okay? Those who say no, raise your hands. And can somebody stand up and tell me why?
Just like there's a half slated, there's a sheet extended over it, and a part broken and taken over. It's like a smooth curvature.
It's a smooth curvature. There's no region of discontinuity in surface. So you say that it appears to be like that. Who says yes? Okay. Come up.
So this line is here, so there should be a line here.
What sort of says is this. Since there is a line here, there should be a line here. Did I get it right? Okay. Is he right? Is he correct? Yes. What is this line signifying? Line of intersection between two surfaces. Which ones? This plane here and this guy here. Right? So if there is a line here, would there be a line here? Yes. Okay. Who disagrees? Good. Yeah. From here to here. So there are two parts. One part is getting truncated over here, okay, corresponding to which there would be a line here. Okay, the other part is going straight out and it's getting truncated over here. Okay, so this arc, folks, try to understand this. So this arc emanates from here, gets truncated here, okay, goes flat, and that constitutes this horizontal surface. Okay, other part of it goes up over here, gets truncated over here, and that corresponds to this plane here. Okay, so there would be a line here.
So that should not be smooth. Sir, you have made smooth.
I am allowed to make mistakes. If I do not make mistakes, many of you guys will be dozing off by now. The fact that I make mistakes keeps you guys vigilant and active. Right or wrong? Okay. This is tricky. And what's your name? Yeah. Chirag. Your question will be answered now. This is an example where just correlating different features and different views will not help. You will have to draw the pictorial view of the object. I'll need some more time. I'll need about 10-15 minutes. Okay? Now, this is what we'll do. I won't say anything from now. Okay? You'll just see a line, either a gray line or a dark line on your screen, and you have to say yes or no. Okay? Okay? Here it goes. Yes or no? Okay, assuming that's a yes. Assuming that it's a yes. Okay? If this is a yes, then these two lines are possibilities. If these two lines are possibilities, then this is how your solid will look like. Okay? Okay? Let me retract these steps. Chirag and others. Line number 1. Line number 2. Line number 3. If I draw these 3 lines, I get to see a solid which looks like this. Okay? However, if I draw this line instead, then I do not need these 2 hidden lines, in which case the solid is going to look like this. Okay? In case 1, I had to work with 3 lines. In the second case, I can just work with 1 line. So there are multiple possibilities. Okay? But the understanding is that you have to work with minimum possible number of lines. Okay? This is what the understanding is. Minimum, there's one more. One more possibility with the same number of lines. Okay? Okay? Yeah? Hop up. Avikalp has another vikalp. Huh? No, all 3 should be complete. All 3 should be complete, assuming that the 3. No. What is given to you is okay, but again, all 3 projections, they should be complete, assuming that the 3 projections are uniquely representing a solid. All 3 should be complete. And how do we know? You have to develop an eye. Minimum possible lines are to be introduced. This is the unsaid understanding, unsaid statement. I can introduce, theoretically, I can introduce a square here, a square there, and I get a block. I can do that. I can do that as many number of times as possible. Nobody stops me from doing that. Okay? But then I'm not looking at multiple possibilities. I'm looking at, folks, so guys in the CSE, there are two things happening in parallel. Okay? There are two things happening in parallel. One is Avikalp is sharing another Vikalp with you. And second is I'm speaking with Anshuman. Okay? And I want you guys to be polite and patient. Okay, so can you take a seat?
This is a curved plane, not
Curved plane.
it starts vertically and ends diagonally.
To address Anshuman and the rest of you, once again, the understanding, the unstated understanding is you have to work with minimum number of lines adequate enough to complete all the three views. Okay? Okay? And to address another Vikalp of Avikalp, this is a plane hold on. This is a plane defined by 4 points which are coplanar or not? They are not coplanar. Huh? A plane is defined by 3 points. It's a warped plane. Twisted. Yeah. It's warped. Yeah? That is something which is not allowed. Okay? So something that you need to keep in mind, try to avoid these possibilities because this is a plane which Avikalp says it's warped. These 4 points, they do not lie on the same plane. Okay, it makes sense because it's 3 points that define a plane uniquely. Okay? Yeah? Was the principle?
There shouldn't be a line dividing the square and the rectangle if they are in the same plane. If they are not in the same plane, then we have to line. Regarding the solution, sir, can you explain to me in what depth of the
Okay, so Kevin, I'll Are you guys with me so far? Who's not? Who's not with me so far? Everybody with me? Good. I'll answer this question later after class. Let me proceed. Okay, it does help if you are drawing the pictorial view of the object alongside when you are in process of correcting the 3 orthographic views. This one. Once again, I'll start drawing. All you need to do is give your consent or give your dissent. Dissent. Say yes or no. Okay, good enough? Okay, so try to figure out the drawing later on. Try to figure out the object later on. This one is quite straightforward. So you have been given the front view, 2 squares as the top and the right. Okay, don't think loudly. Don't think loudly. Just say yes or no. Stay with me. Yes? Yeah? Solid hidden. Solid hidden. What? What are you saying? What are you saying? I'm lost. I'm not with you. You are with me. I'm not with you. What are you saying again?
If that is not in the same line, that left corner and that part have a line.
This thing? Okay. Okay. All right. So are you with me? Center line? Done? Do not miss out on even the center lines when you're completing your views. This example is there on the web page, so if you want, you can take a look. Okay? So I'm done. Thank you.